Hi, everybody. Okay, so now I'm going to go through number 6 on the AP Test Prep section again. So this one, it asks us, hang on, I may have just clicked away from it. In an experiment, a student launches a ball with an initial horizontal velocity of 5 meters per second and an elevation of 2 meters above the ground. So we're going to start above the ground and we're going straight out this time. Notice how I got it right the first time that time. And then it just falls to the ground, right? Because that's what happens when we launch something straight out. And so this is 2 meters. And this is V naught equals 5 meters per second. I'm going to do that V naught X because that's all in the X direction. Okay, and then it says it wants us to draw a horizontal velocity versus time and a vertical velocity versus time. Okay, so I first need to, why don't we first find out time, right? Because they want us to show a graph that goes all the way to the end of the time. So the time that it takes from it to go from 2 meters high to 0 meters high is what we're looking for, right? So we're going to use this one here, except that instead of delta x, notice that I wrote my kinematic friends up on the top. It's very helpful. It's going to be delta y, and this is going to be v naught y and a y. So v naught y is 0 because it's all the way in the x direction, right? So get rid of that guy. And so we're left with delta y equals, and then ay is negative g, right? So I'm going to write this as negative 1/2 g, yeah, g, that's fine. I was going to write 9.8, but I want to keep it all like this for now. Okay, but we're trying to find time, so I'm going to go ahead and solve this for time. So we're going to end up multiplying by 2, negative 2 in fact, and then dividing by g, and then and then square rooting the whole thing. So we end up with t equals negative 2 delta y over g, the square root of that. So that's how we find the time. Now, I solved that like that because this is an equation that some sources will tell you to memorize, but I just think that that seems silly when you could just use the 3 kinematic equations to get it in a second. So I think that those sorts of things, learning where the equations come from and then just figuring them out yourself, can be really, really helpful if your brain has limited memorization space. If you have unlimited, then go for it. Okay, so we're going to plug everything in. So our delta y, we are starting at 2 and we're going to 0. So it's going to be negative 2, right? So we're going to have negative 2 times negative 2 divided by 9.8. And I don't have to make that negative because that's what this negative right here is. So I'll go ahead and calculate that. Good thing I did that part in the calculator. And then when I square root this, I get 0.639. Okay, now I'm going to start by drawing the horizontal velocity graph, just because it's going to be so easy. You're going to really enjoy this. Okay. So our initial velocity is 5 meters per second. So I'll go ahead and make this 5. And I'll label this velocity in the x direction in meters per second. I'll label this time in seconds. And so this is 5. and it's going to go to, we'll call this point 0.639. So it's going to go, and then right there it's going to hit the ground. So that's it. That's all we have to do for that. You don't even need this vertical line if you don't want to put it there. You can just have the line magically stop right here. But once it hits the ground, it's not going to be, well, it might roll forward a little bit. So, but they told us to make it end at that spot. So we don't know exactly what's going to happen after it hits the ground. All right, so that is our X one. So now we need to do the Y one. Actually, I might need some negatives now because it's going down, right? So this is going to be time in seconds. I'll go ahead and make this spot 0.639 because, you know, that makes sense. And we should probably figure out how fast we're going at the end, right? So what's our final velocity? So for that, we use this kinematic equation right here. But I need to modify it to fit our situation. So we start with v equals v naught plus a t. Well, our acceleration is negative g, and our v naught is 0. So get rid of that. Make it v equals negative g times t. Well, that's pretty easy. So v equals negative 9.8 meters per second squared times 0.639 seconds (9.8) negative times 0.639. So that gives us that v equals negative 6.26 meters per second, because the second cancels with the second squared. Okay, so now we know that we're going to start out with a negative velocity. So we're going to start out down here at, oh, sorry, we are not starting there. We're starting at 0, right? And then we're going to end up at a negative velocity of negative 6.26. So I'm going to go ahead and make that right here. Even though that's really hard to read, meters per second. And so what I'm going to do is I'm going to plot a point to there, and I'm going to draw a line like that. And that's all I'm going to do. So that shows that it's going in a straight line. I can guess that the slope of this line is going to be negative 9.8, right? But it doesn't ask us to do anything with that. It said the graph should cover the motion from the instant after the ball is launched until the instant before it hits the ground. Assume the downward direction is negative, which we did for this problem. All right, I hope that helps. Thanks.